in the previous step. So here it proposes me 3D thick beam, any beam, but it's not good because I need to change and move to 2D thin beam. Okay, 2D thin beam. 2D thin beam. Okay, so here we leave the option for enter properties. We go here in the box below where we can insert the geometrical properties. As you can see, the first one, cross-sectional area, is the area. Pay attention that we are working in meters, in the International System of Units, so the area will be in square meters. Then, second moment of area about local z-axis, so is the horizontal centroidal axis for our rectangular cross-section. Here in meters to the fourth power. Eccentricity in y, so in the vertical direction, for us will be 0. This is needed if you want to, I don't know, say that there is an eccentricity between the centroid of your cross-section and the beam axis. You can put it, you can shift it vertically, but in our case, our centroid will coincide with the beam axis. So the line connecting points 1 and 2. So here, the last one should be 0. First and second, they are the properties that we have in the PDF here. Okay, cross-section A is 1, 2. It should be a dot in your PC. I think that it should be 1.2 times 10 to the minus 3 in square meters, okay? While the moment of inertia is 1.6 times 10 to the minus 7, okay? So here, let's come back to this window. Here, cross-sectional area A is 1.2. E, you can write E. You can type any letter instead of times 10 to the minus 3. You can type E minus 3, okay? 1.2 E minus 3 for the cross-sectional area A, and 1.6 E minus 7 for the moment of inertia. Let me check, but I think that was, yeah, 1.6 E minus 7. Okay, here I put a name. The name is uh, 0.03 by 0.04 meters thin, because we selected 2D thin beam, so thin. Apply and close. Then simply assign the attribute as we have done for the first attribute before, okay? If you do double click on the attribute, you can check properties, okay? And maybe change if needed, and so on, okay? Close. So I repeat, attributes, geometric line. Please select 2D thin beam and enter properties, then save it and assign it, okay? These are the properties. Okay, let's move on. The last 3 steps will be assigning material properties, the support, and the loading, okay? So attributes, material. There is also a material library that we will use in the future, but for today we will enter the properties manually. So click on material and then select isotropic, okay? Isotropic. Okay, Young's modulus and Poisson's ratio. For the moment, we will not insert the mass density because in this first analysis we will neglect the self-weight of the structure. We will see in the future how to take it into account, okay? For the moment, just enter Young's modulus and Poisson's ratio. Young's modulus should be 2.09 E11. I will check later, but and Poisson's ratio 0.3. Okay, I will call it steel here. Steel. Okay, but let me check the PDF here. Yes, 2.09 E11 and 0.3. Now we can assign it steel, okay. Material attribute steel assigned to line 1, okay, I check. Did you assign mesh, geometric, and material properties? Okay, someone is positively answering. Okay. Okay, so let's move on. We will create the fixed support for the left node here. So attributes, support. Okay. Okay, as you can see here, you have translations along X, Y, and Z axis, and then rotations about X, Y, Z axis. Free and fixed, two possibilities. There is also spring stiffness, but we will use it future. For today, we are only interested in free and fixed options. And okay, here, in general, you can, for a clamp, a fixed support, you can fix everything here. You can fix all the degrees of freedom and simply assign that constraint to the left node. But we are dealing with a 2D, a plane problem in the XY plane, capital X, capital Y plane, okay? This is the global frame of reference. So here, we only need to constrain 3 generalized displacements. So 2 translations, the X and Y translations, and the rotation about the Z-axis. So the axis perpendicular to the figure, okay? So the 3 needed constraints are the following. Constraint components are the translation along x, so translation in x,